Hey guys, this video will take you through a couple of practice proofs, and then I'm going to ask you to try a couple on your own and then submit to Canvas. I will put hints on a PDF on Canvas for you, but let's step through a couple in the video, and hopefully it'll give you just a little bit more practice in seeing how we can do the various ways we can do a proof with congruent triangles. So grab the 3.3 practice note sheet from Canvas and print it or open it in Notability, and then sort of follow along as we're going through the video. So in this one, we're given perpendicular. BD is perpendicular to AC. So I'm going to mark that perpendicular here. So here's BD perpendicular to AC. So remember, the perpendicular is going to give us right angles. Okay. And then we also know that BD bisects ABC as a given statement. So bisecting means cutting in half. So this angle at the top is cut in half by the blue line. Let me make it blue line here. So this blue thick line cuts in half the angle that is the purple angle. So if that's true, then we can mark this angle here congruent to that angle there. Okay, so start thinking about which of the congruence theorems. Remember, the congruence theorems we have are side, 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 angle, side, angle, side, angle, and angle, angle, side you can use as well. There are 4 of them. So what I'm seeing in this picture are 2 angles that we can get congruent. Your job would be to think about where could we get a side from. Okay, so I'm going to start the structure of the 2-column proof with the statements here. And you could use reasons or justifications over here. And then the given statements, obviously, let's include those as part of our argument. And you can abbreviate as long as the reader can understand what you're talking about. So BIS could be bisects, that's fine. And then these are both given statements. So I'm not sure how much room I'll have, so maybe I'll make this a little smaller, or how much room I'll need, I should say. Okay, so when I look at that information, I see perpendicular and I see bisector, but I have not stated clearly and explicitly to the jury that I have congruent angles or congruent sides yet. So I can't mark any of those with an S or an A. But I do see that since the angle is bisected, I can say that angle ABD must be congruent to angle, let's see, that's CBD. Those 2 angles at the top are congruent to each other. And think about the reason why that's true. How do we know that from the given? And that's because anytime you have an angle bisector, it implies 2 congruent angles. And you can use that implication in your proof. Okay. So there's an A. If you like to keep track of these things, so far we have an A stated explicitly in our proof. Okay. And then let's chase after those right angles down at point D. So because we have perpendicular lines, we can state that angle ABD and angle CDB are right angles. Oops, I'll write the whole word out so you're not confused. Those are right angles. And that's because something from the given told us that. Well, what from the given? Well, it's the perpendicular part from the given that told us that those are right angles. So we can say perpendicular implies right angles. Oops, that would be a 3, not a 4. So we do want to number our statements to match our justifications. So as it goes horizontally across. Okay, so that gives us another angle. So I'm going to mark that we have another angle. And then we need a side, because remember, angle, angle, angle does not work. We're not given any information about the sides, except in the picture, I notice that BD is congruent to itself. That both triangles share BD, and we know that BD is congruent to itself. So since both triangles have that side, remember that's known as the reflexive property. Okay, And now, just keeping track of things that I now have an S. So depending on the order, it's either angle, side, angle, or angle, angle, side. And if you look up here in the picture, I see the angle here, a side next to it, and then an angle. So that side is in between the two angles. So this is an angle, side, angle case or situation. So to finish my proof, I can now say that triangle BAD is congruent to its buddy triangle. By correspondence, it would be BAD corresponds with BCD. Imagine transforming one side to the other. So let's fill in this as BCD. And the justification for that statement, that last statement, would be that we have a pair of angles, then a pair of sides, then another pair of angles. So angle, side, angle is what makes those triangles congruent. Okay, hopefully that makes sense. That's the first one, a 5-step proof. We've justified all the statements. We used all the givens. Okay, now let's try number 2. And this picture is kind of funky, but let's see which triangles they're talking about. They're talking about BDE. So let's mark that. Here's triangle BDE. It's this like wing triangle. And then here's triangle CDF, this purple triangle. All right. Now, looks like we're missing a given. Okay, so it says, let's say we want to prove this by angle, side, angle. What should our other given be? Okay, so let's see. We're given that BD is congruent to CD. That's a given statement. Yep. And please notice that this angle here in the middle and this angle here are vertical angles, so they're automatically congruent. So that's given in the picture, basically, just not given in a statement. But the diagram tells us that those angles are congruent. And then what would we need for angle, side, angle? So think about these pictures. If I drag them off here, I'm not sure if I can do this very well, but I'll try. If I drag that one off, it's maybe a little easier to see if you drag it off. Oops. Okay. There we go. And so now I see that if I'm going to get an angle, side, angle, I must need the angle on the other side of the given side. So that red dot, which is the same as this red dot up here and this red dot up here. So make sure you remember, we can't call that angle B and angle C. We've got to use 3 letters, or you could number it if you want. So I'll go in there and number it just to make our lives a little easier. I'm going to number this first angle as 1 and this second angle here as 2. Okay? As long as you provide a number on your diagram, then the jury can follow what you're doing in your proof. And actually, in this case, so I'm going to state over here that we would need to be given angle 1 congruent to angle 2 in order to finish this proof by angle, side, angle. If we weren't given that information, then we couldn't prove anything because we'd only have a pair of sides and a pair of angles. But okay, so let's assume those are our givens. I'm going to prove this in a different format, which some students may choose to use, and you can use it at any time. Some students like to stick with the 2-column format. Some students like this format, which I call like a bullet list. So I'm going to use a bullet point proof, and I'm just going to say, given, just these are kind of like just sentences, like you're talking it through. Given that BD is congruent to CD, and angle 1 is congruent to angle 2. That's our given statement. And then we can say, since vertical angles imply congruent, notice I'm just doing it like we would speak as opposed to a 2-column format. But I've given the justification. Since vertical angles are congruent, we know angle BDE is congruent to angle CDF. And you could number those two if you wanted to, as long as it's clear which angle you're referring to. Okay, So if we go back and keep track of what we know, here's a side length, here's an angle in our triangle, and here's the other angle. So finally we can say, so it's not a very long proof, just 3 steps. Triangle BDE is congruent to triangle CDF by, I would just say by angle, side, angle. So there's the bullet point proof or bullet list format. You can use that format anytime you want, whichever you think is easier. You could use 2-column or you could use this one. The solutions will most likely be using 2-column just because that's the most common, but you can decide. Okay. And then think about a transformation. So this is number 3 that would make one triangle of number 2 land on top of the other. So if I bring these back, it would be like this triangle to land on top of its buddy over here. Think about what you'd need. Would that be a rotation or a reflection? I'm seeing a line somewhere around here. And if I reflected over that line, I would get left triangle to land on top of right triangle. So I would probably say something like reflect over a line through D and perpendicular to EF. That way it passes through D like we want it to, and it forms a right angle with EF. Okay, hopefully that is helpful and makes some sense. Feel free to rewind as you need to, replay or pause. And then just some hints on the back side. So your assignment for today is going to be finish the front side. Hopefully you've done that as we work through together. And then it's going to be do 4 and 5 mostly on your own. Like I said, there will be hints provided on Canvas. So if you need a hint, you can look there. But just to get you started on some things, so maybe we should mark up this diagram. Here's AB congruent to BC. And we know that BD bisects. So imagine what remember what the word bisects means. But BD, this vertical segment, is cutting in half this horizontal segment. So we can say something about these 2 chunks. Okay. And then it's asking for the correspondence as well. So just be careful when you're thinking about from A to B to D, if that's my triangle, starting at A going to B to D, what 3 points correspond with ABD on the other triangle. Okay. If I think about it, this is probably a 4-step proof or so. Yep. Okay, hopefully that's enough hints to get you started. And then down here, this one's a little tricky because it's meant to be a 3D drawing. So imagine M is a plane that's going into the distance. And then there are 2 triangles that we're looking at. And so we'll start with this purple one. Okay. And if I pulled that off and looked at it in a 2-dimensional manner, it would look like this. So there's that triangle. And then it's hard to see, but basically behind that, there's another triangle. They're kind of lined up, like leaning against each other on a plane. And the other one, if I were to redraw it down here, the blue one, would look something like this as well. So your goal is to prove that those 2 triangles, which it looks kind of weird because it's in a 3D, trying to be a 3D drawing, are actually congruent to each other. You are given some perpendiculars, that BA is perpendicular to AD and BA is perpendicular to AC. And you're given that these chunks down here are congruent. So that AC down here is congruent to AD down here. I think this proof is about 6 steps, 5 or 6 steps. So try to write it up, and I will leave you some hints on Canvas if you get stuck. Remember, you can come see me during our normal class period on Wednesday, tomorrow. But hopefully this helped you get a little better idea of these proofs. So your goal is to finish 4 and 5 and submit the whole thing, front and back, 2-sided, to this assignment in Canvas. All right, I hope this was helpful. Thanks for watching.